Hello, everybody. My name is Emil Vitanov. I am the representative of the Bulgarian company Balkanica Energy PLC, and now I'm pleased to present the project Heat4Cool, designed for the pilot site in Sofia, Bulgaria. Our company main subjects are related to the development and implementation of projects in areas such as waste treatment and recovery facilities, wastewater treatment plants, renewable energy sources, and improving energy efficiency.
Wait, I can put you in the second slide. Yeah.
Oh, the second, yes. So the pilot site in Bulgaria is located in the Boyana neighborhood of Sofia, the capital of Bulgaria. The demo site is a two-floors multifamily apartment building that was completed in 1974. In 2004, excuse me, a total renovation was conducted and new part was added to the building. It has been continuously inhabited throughout its whole lifespan, currently by 4 families. The building had been designed to have a total of 6 apartments on 4 levels, 2 on each floor. Throughout the years, some of them have been combined into separate habitations. Total floor area is approximately 560 square meters. Additionally, there is a heated semi-basement, an open terrace on the last floor connecting to the central staircase. The roof is mostly flat. The building is with refurbished envelope and exposed facades oriented towards southeast and southwest. Some words for the climate. Sofia, the climate is continental with cold winters and warm summers. The relatively low latitude, which is the same as Central Italy, is offset by the position in the Balkans Peninsula, which is exposed to cold waves from Russia, as well as by altitude. The city is located at 550, 600 meters above sea level. Here under, you may see the average temperatures. Maximum temperature 31 degrees Celsius, average temperature 10 degrees Celsius, and minimum temperature minus 11 degrees Celsius. Of course, the building is equipped with a gas boiler for space heating and hot domestic water. On your right side, you can see the natural gas consumption, which is measured 128 kilowatt hours per square meters, 26 kilowatt hours per square meters. Some problem. Okay. So the heating, ventilation, and air conditioning system will consist of 2 electric heat pumps, PCM, protection circuits model heat battery unit, and a photovoltaic system. Centralized heat pump system was chosen because of the higher efficiency and lack of space inside the apartments to put a heat pump in the boiler. The heat pump of 10 kilowatts will be provided, is provided by Heat4Cool company, and it's directly connected to the PCM storage. The heated water is drained through a pipe system to 2 gas boilers. The heat pump unit is installed at elevation minus 2.40 meters. Three-phase change materials, also called heat battery, installed in the vicinity of the heat pump unit. After the heat pump unit, two thermal loops are formed, one of the heat batteries and the other to the heating system. Circulation to the thermal circuit for the thermal batteries will be performed via circulation pump. Circulation pump 1 is indicated. Circulation to the heating circuit will be achieved by means of second circulation pump, which is named circulation pump 2. Only one circulating pump will work at a time. Priority will be given to heat. Priority will be given to heat of the heat batteries through a circulation pump, circulator pump 1. And during the heating season, after the heating batteries have been charged, circulation pump 1 will shut off and the circulation pump 2 will be turned on. The pilot building is divided into 3 thermal zones. Each of them is served by a separate gas boiler and is also linked to the heat pump unit. Thermal zone 1 includes heated rooms at elevation minus 2.40 meters and elevation 0 meters, as well as the staircase. The gas boiler for zone 1 is located at elevation minus 2.40 meters. The heating system for the zone comprised of radiators for elevation minus 2.40 meters and for elevation 0 meter floor radiant heating and fan coils for floor installation. Thermal zone 2. This thermal zone covers the central and western part of the building elevations, which is plus 2.70 meters and plus 5.50 meters. The gas boiler for zone 2 is located at elevation plus 5.50, and the heating outlets for this zone are radiators. Regarding the zone 3, this zone includes the eastern side of the building at elevations plus 2.70 meters and plus 5.50 meters, as well as elevation plus 8.55 meters. The boiler for zone 3 is located at elevation plus 5.50 meters. The heating outlets for this zone will be underfloor heating. So for each heating zone, the following facilities will be installed in vicinity to the gas boilers. Two-way spherical on-off motorized zone valve implements the connections between the heat pump and the heating outlets for the given heating zone. Hydraulic separator provides the hydraulic separations between the heats. Hydraulic separator, which provides for hydraulic separation between the heat pump and the heating outlets for the given heat zone. Three-way spherical on-off motorized zone valve directs domestic hot water directly from the heat pump to the occupants, or redirect the domestic hot water through gas boiler to be heated at a desirable temperature. Some problem with the slide. So on this slide, you can see the work performed so far on the retrofit project in the building. These are modernization of the space heating system in one apartment, added new piping infrastructure to accommodate the new equipment and more complex heating cooling system, installation of the photovoltaic system on the roof of the building, started implementation of the self-correcting intelligent building energy management system. The implemented technologies are 10 kilowatts air to the water heat pump. Heat batteries based on phase change materials for hot water preparation. 3 heat batteries, each of 12 kilowatt hours. 36 kilowatt hours in total. Photovoltaic system on the roof of the building. 22 LG total generation of 40.28 kilowatts peak capacity.
Do you want me to change your slide?
No, it's okay now. It's okay now. On this slide, you can again see the heating system with its main elements. The main source of the heating power, gas boilers, 2 for the whole building, as it's mentioned above, plus 2 heat pumps. Heat distribution in the apartment through radiators with thermostat. It's difficult to move the detached slides.
Yeah, I can do it. So we were here.
The next one, please. Yes, thank you. On this slide, you can see some of the components of the space heating system, part of the pipe infrastructure and a box in which the 2 valves are housed. We focus on 2 of its main features: independent work of the circulation pumps and boilers in the apartments. The valves and circulation pumps are controlled by a separate controller. The next one slide, please. The main characteristic of the hot water preheating system. The main characteristic of the hot water preheating system are displayed here, namely heat batteries connected, 3 in series, heat pump and domestic hot water circuits in Teckelman system, charging of the heat batteries controlled by Siemens PLC, managing the circulation pump based on the data from temperature sensors in the heat batteries. In the pictures on the right, you can see basement heat pump and the heat battery situated right next to it. A photo of the controller can also be seen on the left side. The next slide, please. Thank you. Here you can see how the heat pump, the measuring heat pump above is installed. The 10 kilowatts heat pump is 1 unit device for indoor use. Connection to the building with pre-insulated cross-linked polyethylene pipes. The next slide. Thank you. So this slide shows a diagram of the energy strings of the photovoltaic system. Each string is represented by 40 photovoltaic panels. For each individual string, we have 1 inverter of 6 kilowatts, which is connected to electricity meters measuring the generated electricity. The next slide. Yes, thank you. The solar photovoltaic system is 12.54 kilowatt peak capacity, comprising 42 LG modules. 30 feet modules are mounted on the southeast facing sloped roof, and 9 modules are mounted on the flat roof areas using Renewsaw mounting clamps and A-frames and fixed using hang bolts secured to the roof substructure. You can see these models on the next slide in the picture. Yes. Some words about the solar photovoltaic system. 2 solar edge 6 kilowatt inverters will be used to convert all power from direct current to alternating current to allow maximum possible generation from the system and enable all power to be used for either the heat pump, rest of the building, or to be exported depending on the present demand. The Solar Edge P500 optimizer system will facilitate much greater power generation from the system compared to either string inverter or direct DC, direct current power system, due to the heavily shaded nature of the roof and the limited range which the heat pump can't receive direct current power inputs. The set inverters are to be connected to the internet and the monitoring platform. Two-way electricity meter will be installed by the energy supplier. Besides, lining protection will also be provided on the roof. The next slide, please. This slide shows the intelligence system. Self-correcting intelligent building energy management system. These are the intelligence system, which is represented by a main server through which the individual trackable parameters and monitor it and control it. These are energy consumption, including electricity and heating, inside parameters, including temperature, humidity, occupancy, and illuminance, outside parameters that include humidity, temperature, irradiance. In this way, the main server can control the thermostatic valves receiving data from the respective temperature sensors. This intelligence system includes also a setup monitoring platform, which monitors the photovoltaic energy generation, and SunAmp remote control, which controls respectively the heat pump unit and the PCM storage unit. The next slide. Thank you. This slide shows the monitoring system tracking the data in the apartments and in the building. Monitored data in apartments are listed. You can see them. Indoor temperatures at each thermal zone, humidity and movement, heat and temperatures provided from the heat pump and from the gas boiler to the space heating system, and from the gas boiler to domestic hot water system. Monitored data in the building are heat and temperatures provided from the heat pump to the central heating system, to the heat batteries, and from the heat batteries to the domestic hot water. Electricity consumption by the heat pump and circulation pumps, electricity generation from the photovoltaic system, solar edge inverter, electricity export and import, solar edge energy meter, solar radiation, external radiation sensor, external temperature, the heat pump's temperature sensor. And the last slide. Thank you. As a generation, we can say that the simulations of these retrofits projects show that we can achieve a 30% reduction of electricity consumption as well as reduce carbon emissions by 30% respectively. With the planned partial sale of part of the generated electricity, we can recoup the investment in the project, so name it break-even point, for about approximately 10 years. So that was in broad outlines the presentation of the demo site in Sofia, Bulgaria. Thank you for your attention. I remain available for any questions, inquiries about our demo sites. Thank you for your time.